Welcome back. In this module, we start with mode choice, and in this particular lecture, lecture 36, we start with the mode choice theory. So, the two concepts that would be covered in this lecture is the basic mode choice theory and the factors impacting mode choice. So, we know that in the four-step travel demand modeling process or the trip generation transportation planning process, this is the mode choice is the third step. It comes after the trip distribution step and it precedes the trip assignment phase. And in mode choice, what we do is the trips that are after being distributed, that is after we know that number of people traveling from zone 1 to zone I to zone J, and also not only that, we also know that at what time of the day or in what period of the day, maybe in the peak period, non-peak period, after we divide that distributed trip in between the time periods, then we take up the step of mode choice. That means for a particular time period of the day, for a particular amount, for a particular Tij value, which actually means the number of trips happening between zone I to zone J, we predict the modes that would be adopted by the different people. So, that is the mode choice step that we will cover. So, an individual can select between several travel modes for his journey. The journey could be either a trip or a tour. A trip means there is a starting point and there is an ending point. A tour is when the starting point is home, and then when the after going to anywhere else, and then again the trip returns back to his home. So, that could be called as a tour. Similarly, it could be a non-home based tour where he starts from office and again return back to his office. So, that is why we can have either we can assign or determine the mode choice for a trip or for the entire tour, and but when the mode choice could be only determined if he has either access to those particular modes or that individual can afford those modes. That means, even though certain modes are available for him to take, he may not be able to use them because he neither has, he cannot afford them. Probably he cannot suppose afford a shared vehicle, like for example taxi like Ola or Uber, this kind of modes he cannot afford them, or it could be like he does not have a transit line or like a metro line near his particular stop, near his particular origin or destination. So, in that sense he does not have access to these particular modes, even though those mode alternatives are available in the city. Mode choice is also often consequential upon destination choice, time of the day choice or activity choice. That means, the mode depends on where we are going. That means, even though I have got a car, I have got a two-wheeler and I have got access to use either shared mobility or transit or railway transit or bus transit. So, in that case depending on the destination, I will choose a particular mode. For example, if I am going to watch to go to a very congested area for shopping, probably I will not use my own car, I will take a taxi or a shared mobility vehicle. So, similarly, time of the day also plays a role. For example, I know if I take my car during this particular time period, I will not get parking over there. So, I will not take my car. So, time of the day may play a role, and also the activity choice means what I am performing, means where I am going. So, a combination of both activity choice basically means where I am going, what I am doing, and the entire gamut of things that a person undertakes during his entire tour. So, that depending on the activity also, we also choose our particular mode. So, mode choice models are basically developed so that we can understand or study or evaluate the effectiveness of transportation management policies, and that is primarily geared towards shifting single low occupancy vehicle users to high occupancy vehicle modes. For example, we are trying to shift people from two-wheeler to buses. So, we will try to see that which parameters if we change, or which characteristics if we change, or how we can change the experience of the user, which actually will lead the person to shift to a different mode or primarily towards transit modes. So, that is the primary goal of this mode choice model. We understand what are the underlying reasons why a person or a person of a particular kind undertakes a particular mode, and which are the factors that we could change, or we identify those factors that could be changed, so that we can make them shift to a different mode. So, this is why we want to gather, we want to develop this kind of models, or to gather a priori knowledge, or to understand the reasons why people choose mode. So, we gain this knowledge so that that could be used in developing future modes or future policies, or for predicting ridership of future modes of transport. That means, if I determine that okay, I will introduce a metro corridor in the city, I will evaluate also that what would be the likely effect of introducing this particular corridor. So, that is why we will undertake these mode choice models. So, mode choice models are usually segmented by trip purpose. I am not going with the tour based model at this point of time. I am initially starting with the trip based model. So, that means we are only concerned about a particular trip which has got a definite origin and a definite destination. So, what would be the mode choice for this particular trip? So, first we will segment this trip as per the purposes. That means, for a walk trip, for every trip purpose, the reason why people chooses decisions are different, and so we will first segment it as per purpose. Then, based on the day or time of travel, that means during a weekend I may choose a different vehicle, during normal weekdays, walking day I will choose a different vehicle, or depending on the time of the day I can choose a different vehicle, and also depending on party size. That means, if I have a party of 5, I may not be able to fit in my small car. So, depending on that I may also change my mode. So, we have already studied discrete choice theory. So, that is the underlying theory that is used when we develop these mode choice models. So, there could be many other ways we can also develop mode choice models, but this is the primary way that is actually used, and we already know that in discrete choice theory we use the utility maximization principle. That means, a person chooses the alternative which has got the highest utility, and then we have the probabilistic choice model or random utility model, where we have converted this utility maximization principle into a format where we can predict the probability of a particular mode being chosen by a particular individual. So, this is what is being explained, or this is recap. This is a sort of a reminder for the previous lectures that we have already done. So, in a probabilistic choice model, you see UIN is the utility of particular individual for a particular mode, and there we see that it is composed of two parts. One is the deterministic part, another part is the error part. And as you understand that error is the randomness in the utility, and or amount or things which are not known by the analyst. So, these are the things which takes care of everything else which is not included in the model. And in the deterministic part, we have different attributes which influence mode choice. For example, it could be socioeconomic characteristics of the individual which actually influences mode choice. So, that is VSN. SNN is, that means that it varies as per the individual, and then VXI, this is alternative attributes, that means depending on the mode these characteristics change. And then finally, we have got terms which are interaction between both of this. That means, it is a function where both SN and XI are considered. That means, a particular income group may be more may wish to use a particular mode, or a particular mode is a particular user income group is more prone to using certain modes. So, this kind of interaction terms actually helps us in identifying that what are those close relationship, because it may not be, some income groups have relationships only with few modes, other modes they do not even consider. So, this is the term which actually helps us to determine that. So, these are called interaction terms between socioeconomic and alternative attributes. So, in the mathematical in the random utility theory, we have already said that utility is defined as the function of attributes of alternative I, and also the characteristics of decision maker n and the respective coefficients beta, and E is the error, and epsilon, this one epsilon is the error term, and which takes into account the lack of information of the analyst. And we assume that based on the assumption that we make with the error term, for example, that we assume that the error term for each alternative I is very small, and it has got many small components which will not affect the utility of the alternative much. And by central limit theorem, we said that the errors are normally distributed over the population. We can say that, but we have already learned that we do not, and if we use the normal distribution, then with this assumption of errors, we can this actually gives rise to the multinomial probit models, which is very difficult to solve, and instead we use the more simpler multinomial logit model by assuming that this distribution is not following normal distribution, it is following Gumbel distribution, and this makes it more computationally very simpler compared to the normal distribution model. So, that is how the multinomial logit model or this particular form has come into place. So, we have also this is the particular form of the multinomial logit model, where probability of I alternative is equal to e to the power v I divided by summation of e to the power v I, where for I is equal to 1 to p, that means for all alternative modes. So, at the top I have the utility, we are considering utility of the single mode that for which we are developing probability, and at the bottom term is a summation of the utilities of all the modes, and it is taken as e to the power that particular utility value. So, V I is the system, as we have discussed that it is not U I, we are only considering the V I or the systematic part of the utility. So, the random part is not being considered. So, that is why we have considered a distribution. Now, over here in this side you can see that for different individuals, like for example, individuals are over here x 1, x 2, x p are different individuals, and these x 1 to p are different alternatives, and n is the individual. That means, one individual, but has got is evaluating different alternatives. So, if I had got another individual, he probably would be u 1 n 1 n plus 1, u 2 n plus 1, u p n plus 1, and then n plus 2. So, that means, every individual is considering all these alternative choices. So, u I n 1 n is basically utility of that for that particular individual for alternative 1. So, it again composed of three parts, the deterministic part for V s n, that is the characteristics of the individual, V x 1 that is characteristics of the mode, and V s n x 1 are the interaction terms, and then there is the error term for this particular individual and this particular alternative, and this is there for all the different modes. So, this is the form in which we have to arrange our utility equation for each of the different modes for each individual. So, if we have got 10 individuals and there are 3 alternatives for, and this person is experiencing, or he has option to use, then there would be 30 data and 30 utility equations in that sense. But we have to remember also that all individuals doesn't have options to use all the modes. So, some of them may have 3 or until 1 to p modes, some of them may have a subset of those modes. So, that also needs to be remembered. So, the assumptions of this multinomial logit model are the error is extreme value distributed, which is the Gumbel distribution. Errors are independent and identically distributed. This is the IID property which we have discussed earlier. The variables are not correlated. So, there is no multicollinearity, and any continuous variable and logit transformation of that particular variable of the dependent variable must have a linear relationship. So, we are having individually these are all linearly related, and then there should not be any outliers. That means, we are not going to have any outliers in the data. So, these are the different considerations from which we can start developing or building a mode choice model, and this is how we need to organize our utility equations for each mode. So, now coming to the different factors that impact mode choice. For example, attribute of alternatives, like alternatives means the different modes. We can have travel time, we can have travel cost, we can have walk access distance to that particular mode. If it is a bus stop, that walk time to bus stop, then transfers required. So, different like if I use a bus, I may have to transfer to another bus route, and then only I can complete the journey. Then the crowding level within bus, seat availability within bus, number of transfers, this is only for the transit mode, and reliability of on time arrival, that means how reliable is this particular mode. All these are different modal characteristics which we can include in our model. So, here I have given you the formula where Vxi could be including different components. For example, here we have considered travel time, travel cost, walking distance and the crowding level in that particular mode. So, crowding level, if it is for car, then probably crowding level would not be there, but if it is a bus, this particular variable or characteristics would be considered in the utility equation. So, that also means all utility equations does not needs to be same. That means, the utility equation will vary from mode to mode, and depending on the particular characteristics of that mode, we can add certain new parameters as well. And this beta Tt, beta Tc, beta Wd, beta Cr, these are the beta coefficients for each of these attributes, and these are the ones which needs to be determined when we develop, when we actually solve the model. These are the ones that we need to ascertain when we solve the model. Similarly, we have got socioeconomic variables. For example, different socioeconomic characteristics of the user influence the mode choice. For example, the income of the traveler's household, which could be, there could be many categories of that. So, if we have 4 categories, then we can put them inside the model in form of dummy variables for each category. So, this is income 1 dummy, income 2 dummy, income 3 dummy, and these are the 3 categories which have been taken. So, if there are 4 modes, we need to have 3 dummies. Why? Because suppose for there are 4 alternatives 1, 2, 3, 4. So, I can choose this mode or not. So, it is either 1 or 0. So, let us assume it is 1. Then I can choose 2 or for the alternative 2, I can have a result of 1 or 0. So, I can have a 0 because this is already chosen. Then same for this is already chosen. So, if all these things are, all this data is there, I already know what is the data for this one. So, I do not need to include this one. So, if all of them are 0, I already know this one is 1. So, in that way, I just need to include 3 dummies when there are 4 categories. So, this is the income level, and then we have got gender, because there are only 2 genders being considered. So, only 1 dummy variable has been considered. Then we have age dummies, like instead of making age as a continuous variable, we have used age as a dummy variable. So, there are 1 or 2 dummy variables, and then we have got vehicles owned. This could be a continuous variable or it could be a dummy as well. The number of workers in the family, so this could be a dummy as well as a continuous variable, and then number of adults in the family. So, these are the different parameters or socioeconomic characteristics of the household which actually influences the mode choice. For example, when the number of workers are more, then probably not everybody can go using car. So, some of them may be using transit. So, that actually may play a role in my mode choice. And similarly, number of adults are less, then probably if there is a single adult, probably he will use a 2-wheeler. So, we know that in case of certain characteristics, there are certain propensity towards use of certain modes. So, in addition, there are also interaction terms between alternatives and socioeconomic factors. For example, increasing income reduces the importance of monetary cost in evaluation of modal alternatives, and different genders might also evaluate travel time differently due to difference in responsibilities at home and work. So, that means every individual may have different ways in which they consider a particular attribute to bring in these particular factors, because then these 2 factors are not independent. That means, gender and travel time is not independent. That means, a particular gender is considering a particular travel time together. So, in that sense, we can also combine these 2 terms, and we have got like the first variable, which is income 1 dummy into travel cost. So, that means, we will only consider travel cost for certain types of income. If the income is very high, like suppose income, this one is the 4th category or the 3rd category where income is HIG suppose, for them the travel cost it's paltry, it does not matter, they can choose any mode. But for a income category 1 which is lower MIG, they can only afford to have a bus or a rail, something like that. So, in that sense, we can have this income 2 travel cost. In that way, we can create those dummy variables, gender into travel time. So, these are the different interactions variable that we can create. And finally, once we have these different variables or characteristics that we include in the model or the utility equation, then comes the question of all the things which we have not included. That is where the bias or the alternative specific constant comes in. This represents the utility of an alternative when the values of all other variables are 0. So, this is the beta 0 variable, and beta 1 x 1 plus beta 2 x 2 and so on. So, this is the beta 0 variable. So, when nothing is there, x1, x2, everything is 0, then at least we have got beta 0. So, it represents the utility of the alternative when the value of all other variables is 0. And the alternative specific constants are considered to represent the average effect of all factors that influence the choice, but are not included in the utility equation. So, this is considering everything that is not there, and intuitively we can say that the probability of selection of a particular mode can never be 0, even if the influencing factors are 0. Bias is used to ensure this is the utility equation, is used to ensure this in the utility equation. So, that is why we introduce this beta 0 term. So, as per MNL properties, multinomial logit properties, we have already discussed these two properties earlier when we have discussed discrete choice theory. One is equivalent difference property and the other one is independent of irrelevant alternatives. So, in this particular lecture, we have to use this equivalent in mode choice, particularly in a simple simple multinomial logit model. This property has to be considered, whereas this one will be more important when we explain the nested logit models later on. So, equivalent difference property states that the choice probability of an alternative depends only on the differences in the systemic utilities of different alternatives and not on their actual values. What it means is the absolute utility value is of no importance. The difference between two utilities is the one that is of importance to us. Why? Because if utility of one mode is more than other, then the person chooses that particular mode. So, that means the difference in the utility is of core importance and actual absolute value is not. So, either we can multiply a particular utility with a particular scale factor, or we can multiply with any factor and then all the utilities are multiplied. So, they cancel each other and it does not have any role to play. So, ultimately we have established this earlier that PRI is equal to, I is the alternative, is 1 divided by 1 plus summation of j is equal to I and then e to the power uj minus ui. That means, for every, suppose there are 4 alternatives, I am evaluating the alternative of the second one. So, PR2, the second alternative, is equal to 1 plus summation of here, then e to the power, this is u j minus 2, this u2. So, that means j will be all the alternatives that we are talking about. So, this could be 1 to I or 1 to whichever is the 1 to n, whichever the total number of alternatives. So, that means this is only the difference between this alternative and the other all the other alternatives that is being considered. So, so basically what it means is, that means if I choose one category as a reference category, that means the difference between this category and all other categories is the one that we are considering. So, whenever we are developing a multinomial logit model, we always determine the probability of one mode in reference to another mode. So, that means if I have got 4 modes, my probabilities would be probability of 1 in respect to 4, if I make 4 the reference category, or the probability of 2 in response to 4 and the probability of 3 in response to 4. So, if I know the probability of 1, 2, 3, then automatically I know 1 minus the probability of 1, probability of 2, probability of 3 gives me the probability of 4. So, that is how we can develop this multinomial logit model, and that is being shown over here, where V, dA, SR and TR, these are dA is drive alone and TR is transit, and then shared ride, SR is shared ride. So, these are the 3 equations that are being shown. So, this is the B dA 0, this is the beta 0 coefficient, this is beta 1 coefficient, B dA into income, that is the characteristics of the individual, and gamma T T dA is the travel time of drive alone. Then gamma T T SR is travel time of SR and gamma T T TR is travel time of the transit. So, what it means is, we are using the same gamma value over here. This means that we assume that travel time by dA, travel time by SRA and travel time by TR, travel time itself is considered same in all the equations, on all the alternatives. That means that experience of travel time in all the alternatives is evaluated similarly by every individual. So, that is, but if I feel that transit, people feel like the ride in transit is different, because you are it may not be that comfortable. There are so many crowded people standing over there, so many people standing inside the bus, and you are feeling claustrophobic. So, that experience may not be comparable to an experience inside a drive alone car. So, there the travel time could be different as well. So, there I could have used a different parameter. So, these are gammas are same beta, same coefficients that we are using for all the modes. And here BDA1 and BSR1 and BTR1, so we are using different coefficients. Why? Because these are for different alternatives. Income will have a different effect on each alternative. Similarly, the bias will also have different effect on different alternatives. That's why we are using different parameters. Now, so that means if I want to determine the utility equation, I need to understand 1, 2, 3, 4, 5, 6, 7 parameters. We have to estimate these 7 parameters, but this is cumbersome. So, we can reduce it further. If I take the difference between pair of alternatives for prediction of DA, like the way I discussed over here. So, VSR minus DA, that is that we get this particular value BDA 0 minus BSR 0 minus BDA 0, because it is SR minus DA, and similarly for income we get that, whereas gamma we get the difference in the travel time between these two particular modes. So, in this way we can see that we can, instead of using these two parameters, I can just use a simple parameter for estimating this, and we can say that this parameter is SR in reference to DA. And similarly for this one, it could be BTR in reference to DA. So, this is one parameter, and similarly here we can use one parameter. So, we just need to estimate 1, 2, 3, 4 and 5 parameters. So, that means we are reducing the number of parameters that needs to be estimated. So, this is what is being explained here. Because adding any values to each of the constant and income parameters does not affect the probabilities of any alternative, as we have discussed. Sets of parameters could be replaced by a single constraint, and one alternative is set as base or reference alternative, and preference parameters are set at 0 for base, and other parameters are set as preference difference relative to the base alternative. So, here we can see that we have used one parameter, this is another parameter, and so on. In here we have used this gamma parameter, which is the same travel time by DA, travel time by SR and travel time by TR. I could have also instead of taking the absolute travel time by DA, I could take the difference in travel time by DA and TR, but here we have kept it all the travel times different. So, that is why the equation takes this form. This becomes 0, because we are setting transit as the reference alternative. So, I do not need to estimate these two parameters for transit. So, that is why these are 0, and I just need to estimate this gamma parameter, which is same for all these 3 modes, and that is why I have kept this in the utility equation. So, how do we estimate the coefficients? So, we need to estimate the beta coefficients, and we say that this beta coefficient is, we do it in such a way, so that when we test this, that means the effect of the variable, so that when we put the betas that we choose ultimately should be such that the effect of the variables match with the dependent variable. In other words, MLE maximizes the likelihood of our data to be as close as possible to the system behavior. That means, we have already discussed that we estimate we estimate the coefficient using the maximum likelihood estimation method. We have discussed this earlier. We have already seen this formula in the discrete choice theory. So, it is basically a joint probability density function, which is also called the likelihood function, and it is developed based on the observed samples. Based on the actual values that has been chosen by the individual, we develop this function, and parameter values which maximize the likelihood function is estimated by finding the first derivative of the likelihood function and equating it to 0. So, we take a derivative of this particular formula, and when it is, and we equate it to 0, and for the values of beta which makes it 0, that is the one that we choose. So, it is done through different iterations and simulations, and we change the values of beta in every iteration, and accordingly the one where the highest value is shown is chosen for that particular parameter. Now, we actually are not estimating the beta coefficients for the universal set. We are only doing estimation of beta hats because we are only considering a sample sample of the entire population that for which we are collecting data and then estimating the coefficients. So, this is one part, and the other part is when we develop this likelihood function, we actually use log likelihood because likelihood is difficult to solve. So, due to complexity of the likelihood function, log likelihood is used, and we use specialized software package to actually compute this particular beta values. And there are two parts in the equation. One is of course probability of Jt, which is the probability that the individual t chooses alternative j, and this beta value is the coefficient which would be because of this coefficients this probability value is coming, and then we also use a delta Jt which is equal to 1 if the chosen indicator, that means if that particular alternative is chosen. So, 1 if j is chosen by individual t and 0 otherwise. So, the likelihood function we will only consider the alternatives that are being chosen. So, that is what is being added. So, I will explain this with an example. So, over in this particular example you can see we have got only one parameter. So, because otherwise it becomes complex, you cannot solve it like this. So, this V car, the deterministic portion of the utility for car could be measured using beta 1 into travel time car, and V beta bus could be beta 1 into travel time bus. Now, I have got individual, now I have collected data and I have seen that individual 1 has experienced car travel time of 30 minutes and bus travel time of 50 minutes. That is, this is the characteristics of the alternatives in front of him. He may not have experienced this because he has chosen an alternative which is car, and we know his destination as origin point and destination. So, we know the travel time either by car or bus, and we have put that in the equation. And same for individual 2, his options are 20 minutes in car or 10 minutes by bus, and he has chosen car. And the third person is 40 minutes by car and 30 minutes by bus, and he has chosen bus. So, if you write the probabilities, probability of individual 1 choosing car mode, this is e to the this utility equation which is only 30b. This is utility of the car which is 30 beta divided by utility of both. So, this is e to the power this utility of car plus utility of bus. So, we get the final equation as this, where this is exp is 50 minus 30 which is 20. So, this is the previous form that we have already discussed, and same goes for individual 2, and we get this is the value, and for individual 3 this is the value. I have only considered probability for individual 1 for alternative 1 because that is the one he has chosen. Probability of alternative for individual 2, probability of alternative 1 because that is what he has chosen, and for individual 3 he has chosen alternative 2, that is why I have estimated its probability. I could have estimated all the probabilities, but it is not required because in the log likelihood expression, because of the delta Jt values, we only consider them in the equation in form of we use 1 where it is chosen. So, 1 into ln p11 and 0 into ln p21. So, p21 is actually not required to be estimated, that is why I have not estimated it, otherwise you could have done that. So, this is 1 into the probability of choosing mode 1 for alternative 1, for individual 1 alternative 1, for alternative 2 individual 1 the choice is 0. So, it is not chosen, so it is taken as 0, and then we do it for the second individual, and then we do it for the third individual. So, here he has chosen second mode, so it is 1, otherwise it is 0. So, this is the final form, and this is what has to be maximized. So, when this value, this log likelihood value is maximized, and then to maximize that, so P11 is basically this, P11 is basically this, P12 is basically this. So, for whatever values of beta this equation is maximized, that is the one that is the actual value of beta. So, this is how the software estimates it. Now, if you have got many betas, so there has to be many combinations that actually does that. Many iterations, many simulations that is required. Now, this is how it is done. So, the maximum likelihood estimator shows that value of parameter beta which maximizes the log likelihood value is determined, and this solution is obtained by setting the first derivative of the log likelihood function equal to 0 and solving for beta. We know we take derivative for 0, the slope actually at one point there is no change in the slope, it is the portion that we have to determine. So, that is why we take a derivative, and this shows the graph of likelihood and log likelihood as a function of beta. So, we take the point where slope becomes 0 because we are taking a derivative, and this is the point where we see beta is equal to minus 0.076. So, that is how we estimate the beta value. So, these are some of the factors impacting mode choice. So, for travelers, decision makers, related variables, these are some of the characteristics which are commonly used, like income of individual or the household, number of cars or two-wheelers in the household, number of workers in the household, sex, age group, dummy variables maybe for the household head, then driving license status, transit pass availability, and other variables or like income divided by, per household size or cars per worker. That means these are sort of not interaction term, these are modified variables where we can take income divided by household size actually gives us the amount impact of income on a person's decision making, because the more number of families, the impact of income becomes less. And similarly, for trip related variables, we can include trip purpose, employment density at the traveler's workplace, population density at trip origin, workplace location dummy, and parking availability at destination, accessibility variables, access to transit. So, these are the different variables that we can include in the model. Then mode or alternative related variables, these are total travel time, in-vehicle travel time, out-of-vehicle travel time, walk time, wait time, number of transfers, transit headway, and other LOS parameters for transit or similar kind of modes, and then travel cost that could be also taken. Interaction terms of mode and other variables could be travel cost by household income, then income as a deflator of travel cost, then travel time or cost interacted with sex or age group of traveler, or out of vehicle travel time divided by total trip time. So, these are the different interaction terms that could be also used, and these are most of them, many of these variables are common for all the modes, some of them are only specific to certain modes. For example, out of vehicle travel time would be only considered probably for transit, but for car also we can consider, but we can take a very small value for that. So, these are some of the references that you can consider. So, to conclude, we can say that mode choice models are used to evaluate transportation demand management policies and to evaluate the outcome of introducing new modal alternatives. Both revealed and stated preference data is used to develop mode choice models. While random utility models are most popular, several new approaches are gradually being introduced to handle the increasing complexities and disaggregation levels. And finally, mode choice models are also developed jointly with other choice models. Thank you.